Hi class, in this video we're going to talk about how to take the square root of a perfect square that are fractions. So before we do that, we have to be able to identify which rational numbers are perfect squares when they're in fraction form. So the first step, if your answer is in a decimal form, you want to first convert it to a fraction. And if you can't convert your decimal to a fraction, then it's not possible to have a perfect square, right? So you need it to be in a fraction form. Once it's in a fraction form, you want to simplify the fraction to its lowest terms. And then you want to take the square root of the numerator and the denominator separately. And if numbers on the numerator and denominator are still whole numbers, then the fraction is a perfect square. So for example 1 here, I have 49 over 121. I don't believe I can reduce these any further to the lowest terms. I'm simply going to take the square root of the numerator, and then I'm going to take the square root of the denominator. So in this case, the square root of 49 is going to be 7, and the square root of 121 is going to be 11. Since my answer is 7 over 11, which are both whole numbers on the top and bottom, I would say for 49 over 121, yes, this number is a perfect square. And now for example 2, I have 2 over 9. So in this case, I'm going to do the same thing. I'm going to take the square root of the numerator and then take the square root of the denominator. So the square root of 9 is simply going to be 3. But, however, the square root of 2 is going to be 1.41 dot dot dot, meaning it's going to be 1.41 and it's going to continue on forever. So since the top number is not a whole number, I basically just say no, not a perfect square. Because to be a perfect square, once I get into a fraction form and I take the square root of both the top and bottom, they both have to be whole numbers. And since the top number here is not a whole number, this is not a perfect square. Okay, let's try a couple more examples. Here I have 0.1. Now, first things first, we want to change this to a fraction. Since this is 0.1, that's 1 is in the tens place. I know this is going to be over 10. 1 is here. All right, 1 down, 1 over 10. So 1 over 10, is that a perfect square? Well, let's try to take the square root of 1 and then take the square root of 10. Now, if I take the square root of 1, I'm simply going to get 1. But if I take the square root of 10, I am not getting a nice number, right? I'm getting probably 3 point question mark, question mark, question mark, dot, dot, dot. I don't know what that's going to be. So I'm going to say no, not a perfect square. Okay, example 4, 0.16. Since the 1 is the tens place, the 6 is the hundreds place, I know this is going to be out of 100. And I'm simply going to write 1/6 on the top. So this is 16 over 100. Now in this case, I could technically reduce this. If I take the square root here already, the square root of 16 is 4, and the square root of 10 is, sorry, and the square root of 100 is 10. So I'm going to get 4 over 10 if I take the square root here. But let's just simplify it because, our rules are to simplify this. So I can most likely divide the top and bottom numbers by 4. In this case, 16 divided by 4 is going to be 4, and 100 divided by 4 is going to be 25. So in this case, now let's take the square root of the top and bottom number. So I got the square root of 4, and I got the square root of 25. The square root of 4 is simply going to be 2, and the square root of 25 is simply going to be 5. So I got 2 over 5. Since both top and bottom are whole numbers, I'm going to say yes. This is a perfect square. Okay, now let's move on to example 5 and example 6 here. So for example 5, I got 1.2. Since my number for the 2 is in the tens place, this is going to be out of 10. And then I simply write what I see there without the decimal. 1 and 2 without the decimal, 12 over 10. And if I reduce this by dividing top and bottom by 2, I'm simply going to get 6 over 5. Now you probably already noticed, but if you take the square root of 6 and the square root of 5, they're both not going to be very nice numbers because these are not, perfect squares. Like the square root of 6 is not a perfect square. The square root of 5, 6 is not a perfect square. 5 is not a perfect square. So if you take the square root of 6 and the square root of 5, you're going to get some really rough numbers. So I'm just going to say no. Not a perfect square. Now for example 6, since my 5 is in the hundreds place, this can be over 100. And I'm simply going to write the top number without the decimal. So 225 over 100. Now in this case, if you were to reduce this all the way down, you can see that it would equal, well, I guess I might as well show you the math for it. If I divide the top and bottom number by 25, the top number will now be 9, and the bottom number will now be 4. So if I take the square root of 9, and then I take the square root of 4, I'm simply going to get 3 over 2. Since the top and bottom are whole numbers, I'm going to say yes. This is going to be a perfect square. But notice if I decide to take the square root right here from 225 over 100, the square root of 225 is going to be 15, and the square root of 100 is going to be 10. So it would have showed that it was a perfect square anyways, but for consistency, you want to reduce anyways to its lowest terms and then check.